Yes, right. We completed how to create the partitions, how we need to create the mount point, right? Then today we'll do swap partition. After completing the swap, additional swap partition, so we'll start LVMs, okay? Logical volume management, okay? So first of all, let it complete the swap partition, additional swap partition. So how to know the swap partition, guys? Which command we need to execute to know the swap partition? Yes. Which command do we need to execute to know the swap partition? Yes, guys. Online, can you hear me? Am I audible? What kind of command we need to execute to know the swap partition? Fdisk. I'm not saying how to create the partition. So already we'll have one swap partition while we are trying to installing the operating system. We created one swap, right? Right. So how we need to know the swap details and RAM details? So no one they're bothering about file system hierarchy. So if the faculty is saying this is an important concept, definitely students, they are not going to bother about that particular concept. I know. Yes. So from the day one onwards, I'm saying file system hierarchy is a very, very important, right? No one they're going to bother. But you need Linux without file system hierarchy. Then I don't know how. Okay, top also we can. Okay, top also we can. But we discuss while we are discussing about file system hierarchy at the time. Did you remember cat proc meminfo? Cat proc meminfo, CPU info, right? So memory information, right? So here we'll have the swap details. So 10 GB swap will have, right? Then we'll have 2 GB RAM. Okay. Apart from this, if you want, you can use free-m also. Both are same. Okay. Free-m also it will show you RAM details and swap details. Right, guys? So free-m means MBs. G means GBs. H means human readable format. Right? H means human readable format. Better to use M. So 2 GB RAM will have used and free, shared and buffer and cache. Right? So total how much swap partition will have? 10 GB. While we are installing the operating system at the time, we created 10 GB swap partition. Got it, guys? So 10 GB swap partition we created, right? So for example, at present we have 10 GB, it got full. Assume this. It's not full, it's a zero usage. Maybe if it is got full, right? So the swap partition, we need to add additional swap partition. We need to increase the swap partition. So then how we need to increase the swap partition, we'll discuss. So this is also important in real-time environment. This is also very, very important in real-time environment. How to increase the additional swap partition, how to add the additional swap partition, right? So let's see, guys, here. At present, we have 10 GB. Assume this 10 GB swap partition, it got full, right? Utilized. So it's in use. Then we need to increase 10 GB to 12 GB. 12 GB means we are trying to adding 2 more GB for existing swap partition. Means we are trying to creating 2 GB additional swap partition. Got it, guys, right? So how to create the 2 GB additional swap partition? How we need to attach this 2 GB to the existing? So it will become 12. Now 10 will have, so we need to increase 10 to 12, right? So 2 GB swap partition we need to create, right? So use fdisk command, dv sda, right? Then new partition, p primary, third partition, first sector, we should not give anything. Last sector, we need to define 2 GB, right? So partition 3 of Linux, okay, type Linux 2 GB is set. Then how to print the partition table? P to print the partition table. P to print the partition table. 3 partitions will have SDA1, SDA2, those both belongs to operating system. Just now we created SDA3. So how much? 2 GB, right? And then partition ID 83. And this is Linux partition. We need to convert this SDA3 to SWAP Solaris. Actually, SDA3 is a Linux partition now. Now we need to change the partition type from Linux to Linux Swap Solaris. Linux to Linux Swap Solaris. How to change the partition type? T is an option to change the partition type. Right, guys? So T is an option to change the partition type. Third partition. To whom we need to change the partition type? For third partition, 3. Then guys, we don't know the X code, hex code, right? So to know the hex code, capital L is option. We need Linux swap Solaris hex code, right? Capital L you can execute. It will list out all the hex codes. So let's see, guys. Linux swap Solaris hex code is 82. Right, guys? Actually, 83 is a Linux. 82 is a Linux swap. So Linux swap Solaris. So now we need to change the X code as a 82. See, guys, changed type of partition Linux to Linux swap Solaris. So P to print the partition table. Got it, guys? P to print the partition table. So 2 GB size. See, guys, before we'll have 83, it became 82. Got it, guys? So before we'll have 83. 83 is a Linux partition and 82 Linux swap Solaris. So 82 is a Linux swap Solaris, right? So W to save. Part probe dv sda, then hit enter. Part probe dv sda. Now we created one partition with the 2 GB. We change the partition type Linux to Linux swap Solaris. Linux to Linux swap Solaris. Right, guys? The next what we need to do. So we need to assign the file system. Got it? So we created one partition and then we are trying to assigning file system. How to assign the file system? Usually, which command we need to use to assign the file system? File system mkfs, right? Making file system, right? But coming to here, we are assigning swap, mk swap. I hope you got it. Mk swap is a command, then dev sda 3. So first we need to create one partition. We need to change the partition type. Second step, first step, create partition. Second step, change the partition type. Third step, we need to assign the file system. So how to assign the swap file system? mkfs is a command. With the help of mkfs, we are trying to assigning the file system. See, guys, we assign the file system for dvsda3. So how to verify the file system it got assigned or not? plkid is a command. So dvsda3. See, guys, so dvsda3 is a partition name and it's a UUID, universal unique ID, to identify the partition, and partition type swap. Clear? Partition type swap. We assign the swap file system here, right? Then how to activate this? Let's check the free-m command. Free-m command. See, still it is showing 10 GB. free-m is a command. It's showing still 10 GB. Then how to activate this 2 GB, right? So swap on is a command. Swap on dev sda3, then hit enter. Then let's verify free-m. See guys, it became 12 GB. So before we'll have 10. Now we added additional 2 GB for 10. It became 12. So if you want, you can check the status. Swap on -s. Two partitions will have, see, DM1 and SDA3. DM1, it's a additional swap partition. Sorry, previous old swap partition. SDA3 is a new swap partition just now we created. So 10 plus 2, 12. Right, guys? So we activated additional swap partition. Now we are rebooting this operating system. What will happen? If you reboot the operating system, you're going to lose additional swap partition. We'll have the default swap partition, but we are going to lose additional swap partition. Right, guys? Again, it will become 10 GB. Then how to create the permanent mount point? With the help of mount point, we need to create. So with the help of etc fs tab, so we need to create the permanent swap partition. Even if you reboot, so we are not going to lose. So how to create, we'll see now. So how to create the permanent mount point for swap. So I hope you got it, guys. Simple. Create the partition, change the type, assign the swap file system. Swap on is a command to activate the swap partition. Swap off, switch off for switch offing the swap partition. Okay. So let's see, guys, here. Now again, it will become 10 GB, 12 to 10 GB. See, guys, free-m 10 GB. Now how we need to create the permanent? etc fs tab, right? And here we need to add the entries inside the etc fs tab, right? So dev sda3, guys, here swap you need to provide. Swap and file system also swap, then default and 0 and 0, check sequence and dumping. Save and quit, right? Swap on -a to reset. So free-m, then it became 12 GB, then reboot it. So you can verify, right? Swap on -a, it will activate everything. And then it will become 12 GB. Just reboot and let's verify whether we'll have the additional swap partition or not. So we'll have the additional swap partition because we created a permanent mount point for swap. See, guys, 12 GB will have, right? So if you want, you can off swap off dev sda3, then free-m, it will become 10 GB. Can we able to switch off default? Yes, guys. We can. Zero swap, both switch off. Got it. So both switch off. 10 GB also it switch off and 2 GB also switch off. Then zero swap. There is no swap. I hope you got it. If you reboot both, it will active at a time. Why? Because we'll have permanent mount point in FS tab. So clear, guys. End, madam. Huh? So clear? Yes, no? Online? Right. Very good. So how to delete? How to delete, guys? Huh? Both it got activated. Okay. So my favorite student, he's going to give the answer now how to delete. He's saying something. What is your name? Sai. Sai, tell me. How to delete? AM. VIM. Okay. VIM / etc. FS tab. Right. Delete those entries. Then save and quit. Right. Swap on -A. Right. Still will have the swap partition. If you want, you can check. You need to do swap off. Swap off DEV SDA 3, then free -m, then fdisk DEV SDA, then D2 delete. W to save, part probe to update the new partition table. So clear, guys? In FS tab, it doesn't have. See what we did the modification in FS tab and as well as fdisk command. We are unable to get in history. Remember, in history only commands will have. Right? Yes, no. So clear? Right. So new concept, new chapter, how to create the additional. Fast ga cheptunana. Right. I'll make it slow, no issues. Huh? So I'm unable to hear you. Can you speak? Can you speak a little bit louder? You need commands. Right? Okay. So new chapter, LVMs, logical volume management. Logical volume management, LVM. Guys, usually we discuss as of now standard partitions. If you are trying to creating the partition, you are unable to increase, you are unable to reduce. If you try to increasing, if you try to reducing the partition size, you're going to lose file system. Got it, guys? So the standard partition, it's not that much of worthwhile in real time because in real-time environment, always we need to increase, we need to reduce according to our requirement. Hard disk size, okay? Hard disk size, we need to increase and we need to reduce. Got it, guys? Clear? So, for example, we have one organization called XYZ something, okay? We started one small startup, okay? At the time, we'll have only 10 people, 10 employees, okay? So 10 developers, assume this will have 10 developers. They're writing the code. They're trying to storing the data inside the hard disk. That's it now. So for 10 people, 1 TB hard disk is enough. Okay. 1 TB hard disk is enough for 10 peoples. Right, guys. So as of now, 1 TB is enough. All the 10 peoples that try to storing the data into this 1 TB hard disk. Okay. Maybe after a few months, right, guys? After a few months, right? People's they got increased. Maybe we got a new project, right? So according to that project requirement, we need more manpower. So now 20 more peoples we recruit. For 10 people, 1 TB hard disk is enough, right? Now at present, 30 people you'll have. 1 TB hard disk is enough. So we need to increase the size, right? 1 TB to 2 TB. That's it, no? So we need to increase the size of the storage. At present, we'll have 1 TB. This hard disk you purchase from market, somewhere from hardware shop. So can you be able to increase this 1 TB hard disk as a 2 TB? It's possible. Can we? Can we able to increase the 1 TB hard disk as a 2 TB? We purchase 1 TB hard disk, man. Okay. So we'll have 1 TB hard disk. So can we able to increase this 1 TB hard disk size as a 2 TB? It's not possible, right? Because if it is possible, no one they are going to purchase the hard disk. That's it, na? If it is possible, if you are trying to extending 1 TB hard disk to 2 TB, physical hard disk, I'm saying, I'm not saying EBS volumes, especially AWS peoples. Okay. I'm saying only physical hard disk, right? We can able to see, we can able to touch that hard disk. Okay. So the physical hard disk size, we are unable to increase from 1 TB to 2 TB. So clear, guys. Then what we need to do? We need to purchase 2 TB hard disk according to our requirement. Unnecessary, this 1 TB is waste. And then we need to transfer entire 1 TB data into 2 TB. How much time it will take? We'll get downtime. Maintenance time will get, right? So downtime and maintenance time will get. To overcome those drawbacks, they introduced to us LVMs, Logical Volume Management. LVM, full form, Logical Volume Management. Logical Volume Management. Right, guys? So what we are doing, instead of purchasing the 2 TB hard disk, we are going to purchase only 1 TB. We need 2 TB storage space. Already we'll have 1 TB hard disk. Then what we are going to do? We are going to get only 1 TB hard disk. Right. So 1 plus 1, how much? 2. 2 TB now we'll have. Okay. So we have 2 different hard disks, right? With the help of those hard disks, what we are going to do? We are going to create volume group. What is that? Volume group, VG. VG, right? Volume group you are going to create. Okay. So we'll use this, both the hard disks, and we are trying to creating one volume group that is called VG. Right? In this volume group, we are going to add those both the hard disks. Got it, guys? We'll add so SDA1 and as well as SDA2 both. Clear? SD1, SDA2 both the hard disk. Sorry, not SDA1, SDB and SDA. Two different hard disks, right? SDA, SDB. 1, 2 means partitions. Right. So let's see here. This hard disk and this hard disk we attached into VG. Now this volume group size is 1 TB. That's it now. 1 TB plus 1 TB as a 2 TB. Okay. Okay. 1 TB anana, right. So 2 TB. So got it, guys. Right. So with the help of this volume group, we are going to create logical volume. So logical volume, LVM, right? Guys, how much size of LVM we can able to create? Yes, guys. How much? Maximum 2 TB. It's not like this. You need to create 2 TB. Your wish. If you want, you can create 500 GB. Now, maybe in future, if you want, you can extend 500 GB to 800 GB. If you want, you can extend 1 TB. If you want, you can extend 2 TB. Your wish. I hope you got it. Flexibility. Easily we can able to increase the size. We can able to reduce the size. Maybe if you doesn't need 1 TB, then you can make it again 2 GB. Sorry, 500 GB. I hope you got it, guys. Clear? So this is a use of LVMs. What is a use of LVMs? We can able to increase the disk space. We can able to reduce the disk space according to our requirement. So, but in standard partition, it's not possible. In standard partition, we are unable to increase the disk space. If you create the 2 GB volume, 2 GB only. We are unable to increase more than 2 GB. We are unable to reduce the below 2 GB. So because of that reason, in real-time environment, maximum 90% people, they are going to use LVMs. Logical volume management. Right? So I hope you got it. Exactly what is the use of LVMs. So what is the use of LVMs? We can able to increase and we can able to reduce the disk space without losing the file system. Without losing the file system means we are not going to lose any data. I hope you got it, guys. Right? Okay. So now we need to do the practical session. Guys, did you remember while we are installing the operating system at the time we used LVM mount point? Did you remember? In installation destination, we created manual partitioning, right? Root, boot, swap. At the time we used LVM mount point. We'll have standard LVM thin provisioning and those all stuff. We used LVM, right, guys? So LVM mount point. If you're using LVM mount point, automatically LVMs it will create for operating system. Root, boot, swap, it will be depends on LVMs, it will be created, right? Okay. So we need to perform this practical session means we should have the 2 different hard disks. It's not like this. If we having space that is enough, we are going to create the multiple partition. We are going to consider one partition as a one hard disk. Got it? So let's see here. While we're installing the operating system, what kind of partition infrastructure it got created inside our hard disk. So assume this is 40 GB hard disk. 40 GB only we provided, right? So 40 GB hard disk, right? So DEV which web series? Night. You are sleeping, huh? Night, but you are sleeping now. DEV SDA1. right? 400 MB for boot. Slash BOOT. Right? So this is slash BOOT. So now automatically one more partition it will create, that is SDA2. It's a 30 GB. Automatically 30 GB it will create. Right? And it will create one volume group, guys. LVMs having volume group, right? So RHEL is a volume group it will create by default. By default, RHEL is a volume group it will create. With the help of this volume group, right? This volume group size is 30 GB, guys. So we have two different hard disks, right? Like the same way, only one hard disk will have. Hard disk mean partition. Instead of using the hard disk, SDA2 is a partition we used while we are trying to installing the operating system. Automatically it will create. Okay. So now next, using this volume group, we created /root. How much? 12 GB, I think. Right? And swap. Right? Swap 10 GB, right? So home 8 GB, total 30 GB, right? Slash home. So with the help of this volume group, actually this is an infra we'll have. I'll show you practically, don't worry. This is a hierarchy we'll have in hard disk. Right? So /swap and home. Then volume group is RHEL. So total 40 GB, approximately we utilize 30 change. Right? So go to here, log in into your operating system. How to verify? LSBLK is a command. List block devices. Hit enter. See, guys, SDA having two partition, SDA1 and SDA2, according to this diagram. SDA1, SDA2, right? SDA1 boot, SDA2 30 GB. With SDA2, RHEL volume group it got created. Root, mount point /. Then swap, mount point swap. Home, mount point /home. I hope you got it, guys. Clear? So yes, no. I'll do one thing. I'll reset this. Then we'll do freshly we'll do the practical session. Okay. So got it, guys. Now, approximately how much free space we'll have? 10 GB will have, right? Now we are going to use the 10 GB to perform the LVM task. So clear? Right. So let's see here. So we are trying to creating DEV SDA3, for example, 2 GB, right? Remaining all we are trying to converting into extended. Remaining entire space we are converting into extended. Total approximately 8 GB will have. Then we are trying to creating one more logical volume, SDA5 4 GB. Got it, guys? Clear? SDA 3, 2 GB, 4 extended. Guys, those all primaries till here. This is also primary. This is also primary. And this is also 3 primaries, 1 extended and 1 logical drive 4 GB. Right? This is primary. And this is also primary. Okay. And this is also primary already, you know. So boot also primary, right? So got it, guys. I hope you're clear. Boot also primary partition. Clear? 3 primaries, 1 extended and 1 logical drive. Right. With the help of this primary partition, SDA3, we are trying to creating logical volume. This is also we are going to use. I'm not going to use now. So after some time, I'm going to use SDA5 also, right? So at present, we are going to use SDA3 to create the logical volume, right? How to create the logical volume? Let's see. Guys, first we need to convert this SDA3 as a PV. PV means physical volume, right? We are trying to converting SDA3 as a PV, physical volume. With the help of this PV, we are trying to creating VG, volume group, right? With the help of this PV, we are trying to creating volume group. So VG, right? First, we need to create the standard partitions and we need to convert the standard partition as a PV. So PV, we need to attach to VG, volume group. Volume group size now 2 GB. That's it now. 2 GB. Using this volume group, with the help of this volume group, right? We are trying to creating logical volume. We are trying to creating logical volume, LVM. It may be your wish, maximum 2 GB. Below 2 GB, you can create your wish. Okay, for example, 400 MB LVMs we are creating. If you want, you can increase. If you want, you can reduce according to your requirement. Right, guys? 400 MB LVMs, right? Logical volume. You can increase 400 MB to 800 MB, 900 MB, your wish. 600 MB if you want, you can add. Okay, your wish. So clear, guys. I hope you got it. According to this diagram, we'll do the practical session now. Okay. According to this diagram, we'll perform the practical session now. Okay. So guys, first of all, we need to create the partitions. We need to create the partitions. How many partitions we need to create? 3 partitions we need to create now. How to create the partition? Yes. How to create the partition? Huh? Kirti. Fdisk, DEV, SDA. Then N to create the partition. Right? P primary. So we should not give partition number. You can give if you want to. You can go with the default. Then First sector, we should not give anything, default only, plus 2 GB, right? So P to print the partition table, SDA3 partition it got created. So partition size 2 GB, but partition type is Linux, guys. We need to convert Linux to Linux LVM. T to change the partition type. How we change the Linux to Linux Map Solar is like the same way. Linux to Linux LVM. So third partition to whom? Third partition. So if you don't know the Xcode, L, capital L option you can use, then hit enter, it will store the Xcode. 8E is a partition ID, Xcode for Linux LVM, right? 8E, then hit enter. See guys, change type of the partition Linux to Linux LVM. Change type of the partition Linux to Linux LVM. P to print the partition table. See guys, before we'll have Linux, now it became Linux LVM. 88 is a ID and then partition type Linux LVM. I hope you got it, guys, right? Next, like the same way we are trying to creating the one more partition, extended. The total space we convert into the extended, then N to create the new partition, right? Plus 4 GB. Same type T, fifth partition, 8E, see, 4 GB, 80. So I hope you got it, guys. Extend partition 5. So we are unable to store the data into the extended. Because of that reason, we created one logical drive. With the help of this logical drive, we can able to store the data. So W to save the partition table, and then part probe is a command to update the partition table. So I hope you got it, guys. As of now, I hope you're clear. So clear? Okay. No, we started from 340 onwards, I think. So Vittal. So got it. Right. Next, what we need to do? We need to create the volume, physical volume, right? According to this diagram. So SDA3 is a standard partition. Guys, don't format SDA3 now. Okay, no need to format. Just we need to convert this SDA3 into PV, physical volume. PV create is a command. PV create is a command. DEV SDA3. Got it? Physical volume DEV SDA3 successfully created. Got it, guys? If you want, you can verify. PVS is a command. PV status. See, guys, SDA3 physical volume it got created. Already we'll have a physical volume DEV SDA2. It belongs to operating system. And it having RHEL volume group. LVM version 2. Attributes all. Size. Free size. Free space. So DV SDA3 just now we created, but we didn't attach any volume group to this physical volume. Logical LVM 2 version. Attributes 2 GB size. 2 GB is free. I hope you got it. If you want, you can use PV display also. What happened, madam? Guys, let's see here. Already you know how to create the partitions. A day before yesterday we discussed. Yes. I hope you doesn't have any doubts in partitions, right? Day before yesterday, Saturday, right? Today, what we did, we are trying to creating LVMs, logical volume management. Usually, logical volume management means we need two different hard disks. This is one hard disk. This is another hard disk. With the help of those both the hard disks, we are trying to creating one volume group. With the help of this volume group, we are trying to creating the logical volume. We are going to store the data into the logical volume, not into the hard disk. Remember, okay. But here we doesn't have the multiple hard disk into our laptop, into our virtual machine. రెండు హార్డ్ డిస్క్లు ఉన్నాయా? లేవు కదా. We don't have any multiple hard disk. Because of that reason, what we are doing, already we have some space, 8 GB space remaining will have. We provided 40 GB while we are trying to installing the operating system. From 40 GB, we utilize approximately 30 GB. Remaining 10 GB space will have, right? This 10 GB space we are trying to utilizing to create the LVMs. Instead of adding the multiple hard disks, right guys? So you can create the multiple partitions. One partition you can consider as a one hard disk. Clear? DEV SDA3, you know how to create. SDA4 also how to, you know how to create. SDA5 also you know how to create those all stuff. As of now, we doesn't have any difficulty. Right? I hope you're clear. So past 2 days onward, same concepts we are discussing. Right? So now with the help of SDA3, now we are considering this SDA3 as a one hard disk. This hard disk we are converting into physical volume. How to convert? So this is a command. PV create is a command to convert DVSDA3 into physical volume. Then PVS is a command to know the status, whether the physical volume it got assigned or not. So PVS, PV status, physical volume status. DVSDA3, physical volume it got created. Already we'll have one more physical volume. This is belongs to operating system SDA2. No need to bother about SDA2. Don't disturb. Okay, don't disturb SDA2. If you're disturbing, you're going to lose the operating system. Clear guys? So just now we created DVSDA3 physical volume. Okay, so if you need to know the detailed information about physical volume, PV display is a command. PVS, PV display, both are same. PVS, just it will show you physical volume, it got created like that. But PV display, it will show you detailed information. What is your name? Tejashwini. So Tejashwini is a name. For example, Tejashwini detailed information I need. So Tejashwini initial. So where she is from, right? So where she is staying. So those all the details, detailed information about Tejashwini, like physical volume. PV display is a command, right? Then DEV SDA3. Then PV name DVSDA3. We didn't attach any volume group, and then size 2 GB. And here it's not available. We need to attach, then only it will available, right? And then UUID, PE size, and those all stuff I will tell you, don't worry. PE full form, physical extent, I will tell you what is physical extent size, and those also, don't worry. At present, no need to bother. Right? So successfully, according to this diagram, we created PV. With the help of this PV, we are trying to creating volume group, VG. VG full form, volume group. How to create the VG? VG create, man, simple. No need to write, no need to bother about those commands. Very simple, simple commands. PV create, VG create, PVS, VGS. Got it? So VG create, and then volume group name. You can give any volume group name. If you want, you can give your name also. It's not a problem. I'm providing my VG is a volume group name. My VG. With whom? SDA3. Simple. VG create is a command. Volume group name physical volume name. We are trying to creating the volume group with the help of this physical volume. VG create volume group name and physical volume name. Using this physical volume, we are creating volume group. That's it now. DVSDA3 now physical volume. Using this physical volume, we are creating volume group, right? Then hit enter. Volume group my underscore VG successfully created. Then we need to verify really the volume group it got created or not. We need to know. VGS is a command. Sorry, VGS is a command. Okay. See guys, RHEL already will have. This belongs to operating system. No need to bother. My underscore VG just now we created. My underscore VG is a volume group name. Volume group name. It having one PV. It having one PV. There is no logical volumes. There is no snapshots. Guys, I'm not going to cover snapshot here. If you need snapshot, Linux admin. Okay. So how to create the logical volumes only. So I'm not going to cover snapshots and those all stuff here. Snapshots. And if you need advanced disk management concept like status, video, like logical volume will have status. They introduced to us from 8.0 onwards. Status concept and video concept, virtual data optimizer. So in 1 TB hard disk, you can store 3 TB data, 3 times more objects. You can create 10 times Dockers, means containers and virtual machines. Got it? Those all it will cover in admin, not here. Okay. Right. So let's see guys here. My underscore VG 1 PV 0 LVs means there is no LVMs, there is no snapshots. Then read write permission will have attributes 2 GB is free. If you want, you can use VG display also. VG display and VG name, you'll get the detailed information about that particular VG. So VG name, my underscore VG, then LVM2, then metadata area, meta sequence number, and those all stuff will have here, will have read and write permission, resizable permission. See guys, size 2 GB. Guys, remember PE full form physical extents. By default, physical extent size is 4 MB. I'll tell you, don't worry. Okay. So remember, by default, physical extent size is 4 MB. By default, physical extent size, right? Okay. So now we create a volume group successfully. Then with the help of this volume group, we are trying to creating the logical volume. So how to create the logical volume? Let's see. LV create, simple. PV create to create the physical volume. VG create to create the volume group. LV create to create the logical volume. Okay. LV create to create the logical volume. Then hyphen capital L. Capital L stands for length, guys. Length, size of the logical volume. Size of logical volume. LV create space hyphen capital L, then size of the logical volume you can define maximum 2 GB. And we are trying to providing 400 MB. Okay. We are trying to providing 400 MB. Hyphen N means name. Name we need to provide, right? Logical volume name we need to provide. Hyphen N LV, otherwise my underscore LV with my underscore VG. Simple. LV create is a command. Hyphen capital L is an option. 400 MB size we provided for logical volume, maximum 2 GB. More than 2 GB we are unable to create, remember, because volume group size is 2 GB. Right. Hyphen N. N means name. Name of the logical volume. Any name you can give. It's not like this. You need to provide my underscore LV, your wish. Okay. So my underscore LV is a logical volume name with whom we are trying to creating with volume group. My underscore VG is the volume group name. Right. So let's see guys here. So this is a volume group we'll have. Now we are trying to creating the logical volume with volume group. Simple. Then hit enter. So logical volume my underscore LV, it got created successfully. Then we need to verify. Simple. LVS is a command. See guys, how many logical volumes we'll have? Home, root, swap. Those home, root, swap, it belongs to operating system. Just now we created my underscore LV. Just we created my underscore LV and it's connected to my underscore VG and size 400 MB. Then LV display detail information. See guys here, LV display DEV slash my underscore LV slash my underscore, sorry, VG slash my underscore LV. This is a path we need to store the data. We should not store the data into the DVSDA3 now. We need to store the data into volume group. Because DVSDA3 is a standard partition, you are unable to increase the size of DVSDA3. Now DVSDA3 size is 2 GB. With the help of DVSDA3, we created one volume group, a logical volume. So this is a logical volume path. We need to store the data inside this logical volume path. And logical volume name, volume group name, UUID, read and write permission, C size 400 MB. Guys, LE stands for logical extents. PE stands for physical extents. LE stands for logical extents. Logical extent size how much? 100. Physical extent size how much? 4 into 100? 1. 4 into 1. 4 into 100. 400. 4 into 1, 4 only, right? So actually, I'm a bit poor in maths. So compared to me, you people's right. I'm unable to understand really. Huh? So, so 4 into 100. 400. Physical extent size is 4. Logical extent size is 100. 4 into 100, 400. Means 400 logical volume will have. Inside this 400 logical volume, 4 chunks will have. Each chunk size is 100 MB. Chunk means small logical parts. I hope you got it, right? Okay, so clear guys, how to create the logical volume. Then how we need to store the data. Guys, if you are unable to understand, don't sit simply. So you can ask me, then I will repeat, it's not a problem. If you are simply sitting, how I can able to understand, tell me. Right? So I doesn't have face reading techniques and those all stuff. Okay. So somewhat I have, I can able to find an offline, but online peoples, there is no face reading, there is no facial expressions. Huh? Friday is a first. Friday is a first Saturday. Monday is a second Saturday. Second Sunday now. Okay. Right. Okay. Okay. I understand. Manikandan. So Friday, first Saturday. So they are going to think. Okay. Monday is a second Sunday. Means Sunday already completed. So people they are thinking Monday is a second Sunday. So that is what he's saying. Right? Okay. So, right, we'll continue. That's it now, Manikandan. I think you're saying same. So, right? Okay, guys. So let's see here. I hope you're clear how to create. Right. So how to store the data? How to store the data? Right. So usually people's they're considering 4 days as a holiday, according to Manigandan. Friday, first Saturday, again Saturday will have Sunday, and Monday is a second Sunday. Right. Okay. Right. Good example. Right. So guys, please don't sleep, guys. Don't sleep. Okay. In Europe, 4 days holidays. So because of that reason, people they are becoming lazy. Huh? Right, guys. How to store the data into logical volume, right? Guys, we need to format first. MKFS hyphen T. Guys, I'm using ext4. If you want, you can use XFS also. XFS, we have one small, actually, it's not a drawback. We doesn't have the reduce option in XFS. We can able to increase, but you are unable to reduce. If you're using XFS, it's a bit difficult to us to reduce because we need to take a backup entire data. Then we need to delete the current LVM. Again, we need to reduce the LVM size. Then we need to recover the data from snapshot. So it's a very lengthy process, right? So, but we can able to increase, we can extend, it's not a problem. Maybe if we having 400 MB, then you can extend from 400 to 600, 600 to 800 MB like this in XFS. But coming to ext4, we can increase, we can able to reduce. So I need to show you how to increase, how to reduce. Because of that reason, I'm using ext4. In XFS, you are unable to reduce. We should do some different thing, right? So we need to take a snap, then delete, then again create, then we need to recover the data from the snapshot, right? But coming to ext4, it's not like this. You can increase, you can reduce according to your requirement. Clear? So I'm using ext4 file system for this LVM. My underscore bg slash my underscore lv, then hit enter. So how to check? blk id is a command, block id, right? Then dev my underscore vg, then my underscore lv. Got it? So clear. Next, what we need to do? We need to store the data. How do we need to store the data? We should create the mount point. mkdir home student desktop. We are trying to creating one directory. If you want, you can use mnt also, right? Then mount is a command. Then dev my underscore vg, my underscore lv, home student desktop dir1. Already we done those all stuff, right? Then hit enter. So let's check df hyphen capital th. Got it? ext4 size approximately 400 MB. It mounted on dir1. See. Open just attention button. Okay. So let's see here. Thank you. Clear, guys? I hope you got it, right? Right. So now how we need to store the data? CD, home, student, desktop, dir1. Then try to create view files. Guys, in ext4, automatically one directory will create a last place found for dumping to get the backup. Okay. So no need to bother about that. Okay. I hope you're clear. Then if you reboot, what will happen? You're going to lose file system. VLK ID for what? Rahul. Rahul, VLK ID to know the UUID and partition type. Universal Unique ID, UUID full form. Right. Yeah, welcome, Rahul. So let's see, guys, here. We don't have any mount point now. It got deleted. So how to create permanent mount point? VIM. VIM, it's a editor, man. So we should not say VIM, VIM. We need to say etc fs tab, we need to edit. VIM is a editor. See, simple. You need to edit XYZ file with the help of Notepad. So instead of XYZ, are you going to say Notepad? No, right? Which file we need to edit means you are giving the answer Notepad. Huh? So which file we need to edit? etc fs tab file with VIM editor. So DEV, SDA, don't give SDA. My underscore VG, right? Home, student, desktop, dir1. Then file system, ext4, default 007 bit. Right? So clear? Then mount -a is a command. See, it got created. So even if you reboot the mission, you're not going to lose this mount point. Okay. Okay. See guys, we have, right? How to actually the LVM purpose, we need to increase, we need to reduce. How to increase the size from 400 MB to 600 MB, 800 MB like this, right? Clear? Okay, right. How to increase? Let's see, guys. Guys, LV extend is a command. LV extend hyphen capital L length plus, already we'll have 400, right? You can add plus 200 MB. DV to whom? DV my underscore vision, my underscore LV. Extending logical volume my underscore LV to 600 MB. Got it? Before 400 we'll have, now it became 600. If you open this, you'll have the data, you're not going to lose the data. Means there is no, there is a, we didn't lose the file system. Without losing the file system, we increase the disk space, right? So if you want, you can verify DEV, SDA, DEV, sorry, CD, home, student, desktop, then DIR1, check the list. Just simple, LV extend is a command, hyphen capital L is option, plus we are adding 200 MB, DEV, my underscore VG, my underscore LV. Total 4 plus 2, 600 MB. Right? Okay. So I hope you're clear how we need to increase. How to reduce. Guys, it's not that much of easy. We need to follow a few steps. First of all, we need to unmount DEV, my underscore VG, my underscore LV. Unmount it. E2FSCK is a command. Hyphen F, DEV, my underscore VG, and my underscore LV. With the help of this command, we are organizing the data. Right? Then hit enter. So it's checking inode blocks, directories, status, structure, connectivity, everything it will check. E2FSCK. E2FSCK. Done. Guys, on one more thing, before we didn't discuss actually, I'll tell you. Resize is a command we need to use before. Actually, it got increased 400 to 600 MB, but properly it is not going to increase. We need to execute resize FSTK DVSDA. So while we are trying to extending at the time, I forgot that command. Okay. So clear. So resize FS, resize to FS. Okay. Resize to FS is a command, guys. This is for ext4 to resize the file system. Right. If you're using XFS underscore growfs, resize to FS for ext4, XFS underscore growfs for XFS. Here we are using ext4, right? Because of that reason, we need to use resize to FS. Then what we need to do? DEV, my underscore VJ and my underscore LV, right? To 400 MB. Got it, guys? Already 400 MB will have, like that is saying, actually it's not updated successfully. Okay, let's see here. Resize to FS. Actually, we need to execute in extending. Actually, we did 3 steps, right? First, what we did, LV extend plus 200 MB, right? DEV, my underscore VG and my underscore LV. And after that, you need to execute this command. After that, you need to execute this command. Okay. We forgot between before, right? Then reducing, unmounted, execute E2FSCK, then resize to FS, resize to FS, right? Then DEV, my underscore VG and my underscore LV, 600 now will have 600 to 400. Resizing the file system on 600 to 400, right? Then LV reduce hyphen capital L minus 200 MB. Simple, guys. We have 400. We increase the size 400 to 600, right? Now what we are doing, again, we fix the size as a 400, remaining 200 we are removing. Got it? Yes, no. So LV reduce space hyphen capital L minus 200 MB now. Then DEV, my underscore VG and my underscore LV. Yes, guys, maybe if we having the data more than 400 MB, it's providing the warning you are going to lose. Anyway, we doesn't have that much of data. It got reduced 600 to 400, right? Mount hyphen A, then hit enter, right? Then DF hyphen capital TH. See, guys, 600 to 400 MB again. Before we'll have 600, right? It became 400 MB, right? Let's verify. CD home student desktop dir1. We have the data. So like this, you can increase, you can reduce. Clear? I hope you got it, guys. You can, Pavan. I'm coming. I'm coming. I'm coming, Akash. Don't worry. As of now, I hope you're clear. Clear, guys? How to increase, how to reduce. We can able to increase, we can able to reduce. Now, we need to increase more than 2 GB. Can we? No. Because VG size only 2 GB, right? So we are unable to increase LVM more than 2 GB. It depends upon VG. Means now we need to increase the VG size. Now we need to increase the VG size. How to extend the VG? Now we'll discuss. Okay. Guys, I'm going to use now DVSDF5. So we are trying to attaching this DVSDA5 to, we need to convert as a physical volume, and this physical volume we need to attach for DVSDA, to VG. It will become 2 plus 4, 6. Then you can extend LVM more than 2 GB till 6 GB. Clear? So how we need to, I hope you got it, Akash. If you need to increase LVM, first of all, we need to increase the VG. Then only we can able to increase the LVM size, right? So let's see, guys. VG extend hyphen. No need to provide hyphen. Just give the name my underscore VG. Then new volume DVSDA5. Guys, automatically it will convert into PV. This PV it is going to attach to VG. So DVSDA5 physical volume set attached to VG. Let's verify VGS. Two physical volumes will have PVS, SDA3, SDA5, both belongs to my underscore VG. Right, guys? VG display, my underscore VG, 6 GB, 5.99, right? So clear? I hope you got it, right? Okay. Now, I hope you're clear how to extend the VG, how to reduce PVS. See, guys, now our intention is we need to keep SDA5. We need to remove the SDA3. I hope you got it, right? So here we need to reduce from 6 to 4 GB. Means 2 GB volume we need to remove. So in this case, we are unable to remove directly because the LVM infra and data, everything will have into SDA3. Right? It's used from SDA3. So because of that reason, if you try to reducing SDA3, you'll get one error, SDA3 in use. First of all, we need to migrate the LVM and data from SDA3 to SDA5. PV move is a command. Physical volume move, guys. DVSDA3 to DVSDA5. Physical volume move. Right? Now PVS. See, guys, before it having 1.6, now it became 2 GB. Before it having 4 GB, now it became 3.1 or 3.61. Means this 400 MB we moved from SDA3 to SDA5, right? Data and LVM, everything it got moved from SDA3 to SDA5. Now SDA3 is free. Now we can remove. VG remove, VG reduce, guys, don't give remove. Remove means it will delete. VG reduce. SDA3. Remove SDA3 from volume group my underscore VG. Got it. Let's check PVS. See, it got removed. Let's check VG display. 4 GB. But even though you are not going to lose the data, I hope you're clear, guys. We can reduce, we can increase, your wish. You can extend, you can reduce. It may be volume groups. It may be logical volumes. Clear? Right? Now we'll see how to delete. Right? Go to FS tab. Remove those entries. Guys, we'll have entries, right? We need to remove those entries in FS tab. Save and quit. Unmount it. DEV, my_VG, my_LV. Right? Unmount. Then LV remove is a command. Yes, it's like warning messages we got. It's providing the warning. You're going to lose your data. You're going to lose your LVM like that. Yes, anyway, we need to delete, right? Yes. Clear? VG remove. PV remove. How many PVs? SDA 3, SDA 5. 2 PVs, right? That's it. Like this, you can remove. Then you know already. Go to fdisk and then delete the partitions. Clear, guys? I hope you got it. Yes, no. We have one exam question. In iSCSI also you can create, Rahul. So iSCSI means SAN protocol, right? We have two types of SAN protocols, FC and iSCSI. Even if you're using iSCSI also, it will provide the solid drive. So with the help of the solid drive, you can create LVMs. It's not a problem. Okay. But it's a network drive. But we can able to create the logical volume with network drive also. It's not a problem. Will do. Rahul. So iSCSI target initiator 2 will have, right? Do you know about iSCSI? Wherever if you want to connect, initiator will have, target will have. Target means server. Initiator means client. We are going to create the network storage into target. We are going to share those volumes into initiator. We can able to create the logical volumes with the help of that network storage in initiator. If you want, you can use LVMs also while you are trying to creating the targets. Right? High availability means it depends upon SAN provider. So target 24/7, we need to maintain the targets. Then we'll have the high availability. Right? So nowadays, most of the people, they are using clouds, right? So before we'll have SAN, IBM people, they have the SAN service. Usually IBM people, they are going to provide the SAN services. So, okay. So nowadays, most of the people, they are using cloud. Clear?